Hey there, science fans! Today we're diving into the world of CMOS chips. These tiny wonders power almost everything electronic around us, from your smartphone to your fancy new smartwatch. CMOS stands for Complementary Metal-Oxide-Semiconductor. It's a mouthful, I know. Think of CMOS as a tiny city of microscopic switches turning on and off billions of times per second. These switches control the flow of electricity, kind of like traffic lights managing cars in a busy city. The more switches, the more powerful the chip. Pretty cool, right? These chips are made using a process called photolithography, which is like using a teeny tiny stamp to create patterns on a silicon wafer. We'll get into that more later. These chips are super important because they help make our devices smaller, faster, and more energy efficient. Stay tuned as we delve deeper into the fascinating world of CMOS fabrication. Making a CMOS chip is a complex process, kind of like baking a cake but with a lot more steps. First, we need our base, a silicon wafer. Silicon is a semiconductor, meaning it can conduct electricity under certain conditions. Next comes photolithography, our tiny stamp process. Imagine shining light through a stencil onto a cake covered in light-sensitive frosting. The exposed parts harden, and we can wash away the rest. That's how we create the intricate patterns of circuits on our chip. Now, we need to dope the silicon, which means adding impurities to change how it conducts electricity. It's like adding different flavors to our cake. We use a process called ion implantation to shoot these impurities into the silicon wafer. After doping, we etch away unwanted material similar to carving designs into our cake. Then we deposit layers of materials like metal and insulators, just like adding frosting and filling to our cake. We repeat these steps many times to build up the layers of our chip. You might be surprised to learn that those tiny, powerful chips in your devices start their journey as plain old sand. Silicon, the main ingredient in CMOS chips, comes from silica, the main component of sand. First, we need to purify the silica to get pure silicon. This purified silicon is then melted and grown into large cylindrical crystals. These crystals are sliced into thin, round wafers, just like slicing a loaf of bread. These wafers are polished to a mirror-like finish, making them ready for the chip-making process. It's like smoothing out the frosting on our cake before decorating it. The smoother the surface, the better the circuits will be formed. Remember, each wafer can hold thousands of chips. Once the chips are made, they're tested rigorously to ensure they work perfectly. Then they're packaged and shipped off to be used in all sorts of electronic devices. CMOS technology is everywhere. It's the driving force behind the digital revolution, making our devices smaller, faster, and more power efficient than ever before. Your smartphone, laptop, tablet, and even your smartwatch wouldn't exist without these tiny wonders. From browsing the internet to playing games, streaming movies to connecting with friends, CMOS chips make it all possible. They're the unsung heroes of the digital age, quietly working behind the scenes to keep us connected and entertained. As technology advances, CMOS chips will continue to shrink in size and increase in power, leading to even more amazing innovations. So next time you use your favorite electronic gadget, take a moment to appreciate the incredible science and engineering that went into creating the tiny but mighty CMOS chip at its heart.